Welcome to the Crazy Hat Chemist. Here we are again with equilibrium and reaction rates, video number 23. Bam! Okay, introduction to kinetics. So, at the very beginning when we talked about kinetics and thermodynamics, we said kinetics is a rate, and the rate is a change in concentration over a change in time. Okay, so let's see what that looks like graphically. So here's this really nice graph where you have the concentration or moles of bromine. At the very, very top of this graph, it's 0.1. And at the very, very bottom, it goes down to 0 over time. And you should see, over time, there's a decrease in the concentration. So I'm going to point out a couple of things here. So one, take a look at this line right there. That black line, which is giving you the slope of that initial concentration. That initial concentration is very steep. That slope is very steep. That means that the reaction is going very fast. Let's take a look at another time point a little bit further down. We look at that one, we should see that this slope is not nearly as steep, and therefore the reaction is starting to slow down. Okay? And we'll look at another time frame, and look at this slope. This slope is even less steep than the previous one. So over time, that means that the reaction is going slower and slower and slower. I want you to think about why that might be, okay? All right. So take a look at this graph. The R stands for reactants, where there's a green line. The P stands for products, where there's a red line. We're going to right now ignore the two blue lines, the light blue and the dark blue. Don't worry about those. I'm really interested in the green and red lines right now. Look how high the R, the green line, is to begin with. It's at 100%. And at the P, the products, that line, the red line, is 0 at the beginning. So the R stands for reactants, and you have 100% reactants at the very beginning of the reaction, and the products, you don't have any products at the very beginning. Over time, that means that the reactants are going to decrease, and the products are going to increase. So I want you to see this on this graph with some arrows. So take a look at this. The reactants at time initial are 100%, and they're going to decrease over time. They're going to decrease over time, and that's very similar to the slope that we had before, okay? And then over time, you're going to have no more reactants eventually at the end of the reaction. Then, if we look at the products, you don't have any products at the initial time frame, okay? But they are going to increase as we move through this reaction over time, okay? So you're going to look at the steepness of the curves. The initial rate of the reaction is fast to begin with and slows with time because fewer reactants are available over time. That means that the reactants, there's fewer reactants, and it takes longer for those reactant molecules to get together to form a product. This is part of the kinetic molecular theory. The reactants need to hit each other with the correct amount of energy and the correct orientation to form a product to go on to the other side. Okay? So let's take a look at this one here. Okay? So again, rate is concentration over time. So change in concentration over change in time. So equilibrium, and we are talking about equilibrium, so that's why kinetics and equilibrium are intermixed here. Equilibrium has been reached when a steady rate of consumption of reactants, that's the blue line, and the production of products, that's the purple line, as seen in the flatness of the curves. So initially, the blue line is 100%, and the purple line is 0%, because A are the reactants, B are the products. And you should see a little bit past 1 second in time, then the two lines just level off. That's when equilibrium has been reached. Equilibrium has not been reached until those two lines are level with each other. Okay, good. That was that next video. How do you like the shark hat? I love the shark hat. Okay, so give me a thumbs up if you like that, and I'll see you next time. Bye now.